As the first video that I'm asking you to do, outside of this, I want you guys to take a second and look at the multiple redundancies that I have in play for you while I'm gone. One of them is actually just the class calendar, which you can access by going to the class website and just looking at the calendar events there, or you can access on your phones or something. I've actually added attachments to it this time, just for this week. If you look at the single attachment under attachments, it's not a link, it's actually a physical attachment there. This is going to download a PDF that's the complete lesson plans given to the sub for every day. So just to give you an idea of what's expected and what you can do. That attachment, go back to that, actually has attached to it every document, including a class list of all of you, but every document that I'm going to hand out for that day and all the files that the sub would want for the day. You don't need to use that. You can just use the classic links like I've always had on the calendar as well. Sorry, here they are. Secondly, another redundancy is that at Google Classroom I've copied every assignment, and this is how you're going to turn assignments in, but we'll talk about that. We should have talked about that in class. So that's duplicated here as well, and you can just kind of look at the left and see what to do for a particular day. Of course, if you have any questions, you can contact me, but this should be pretty obvious and evident regardless of if you follow the calendar or if you follow Google Classroom. And of course, as always, you guys need to be posting questions on Google+, which I'll be responding to as best I can. Let's get started. There's going to be two basic applications of logarithms that we're going to do. One is going to be solves. We're going to be solving some things, and we're doing 10.6 after 10.8 because we are including e. So that's why you're going to see us use our own worksheets for this, because we specifically wanted to include e in this stuff. You're going to see some solves. You're also going to see some change of base. So you're going to need your calculator for this. Specifically, I want you guys to challenge yourselves to use your calculator and to do that change of base theorem that we talked about before spring break. I know that was a while ago. So let's just dive into some solves. Here's a basic solve. 16 to the 3x minus 1 is equal to 1/2 raised to the 2x plus 1. Now, one thing I can note with this is we can go back to methods that we did before. 16 is the same as 2 to the 4th power, and 1/2 is the same as 2 to the negative 1 power. They can both be expressed with a common base of 2. And I can use my power of powers rule to say that this is the same as 2 to the 12x minus 4, and this is the same as 2 to the negative 2x minus 1. Now, it's worth noting that at this point we have something that we've only alluded to at times called the exponential property of equality. And well, we have mentioned it in the last chapter, but what I'm actually doing, and I just want you to write this once, is I'm actually taking the log base 2 of both sides equals the log base 2 of 2 to the negative 2x minus 1. And when I take the log base 2 of both sides, that's the operation that actually cancels out the base of 2 and gives me just the exponents by themselves. And then I can go ahead and solve. 14x is equal to 3, and x would be 3/14. But we're going to have some other problems, and here's one of them. Let's say that I have 4 raised to the x minus 1 is equal to 3. This problem requires a logarithm because there's no way to just change 4 and 3 into the same base. There actually is a way, but you're not going to use that until calculus. You would be able to understand it now. There's just no need to. But what we're going to do is I'm just going to say convert this from exponential form into log form. Remember that yesterday we also mentioned that if you are ever in doubt, try just going back and forth between exponential form and log form. Log base 4 of 3 is equal to x minus 1, or x is equal to log base 4 of 3 plus 1. Now, this is a perfectly acceptable solution if I'm solving by paper. However, if I want to put it into a calculator ready mode, meaning a mode that I could enter into a calculator, enter into any calculator, not just mine, TI Inspires that have logs at different bases. What I'd want to do is I'd want to change the log base 4 of 3 into something else. And what I'm going to ask you guys to do is actually use the natural log. ln of 3 over ln of 4, and then plus 1. So this would be a calculator ready mode, and it is actually perfectly just as simplified as the one before it. It's not proper to say that one is more simplified than the other. If I plug that into a calculator, and let's just say my calculator ready mode would want that, then this just becomes a simple operation of typing in natural log of 3 divided by natural log of 4, and then plus 1. Okay, so that would give my approximation of about 1.79, and we could move on. Number 3, and this one's going to take a little bit of time. Sorry, just kind of converting that. I have 3 to the x power is equal to 4 to the x minus 1. This is a totally new problem type, and as such I'm going to kind of split it down and start to describe what I'm going to do here. We need a way to get the exponents out of exponent forms. So what I'm going to do is I'm going to take the log of both sides. You can pick whatever log you want, and I'm going to ask that you pick the natural log. Honestly, because it's just simpler to write, but also you're going to use it more in higher classes. So we're going to go the ln of 3 to the x is equal to the ln of 4 to the x minus 1. My next step is going to be to use the power rule, meaning I'm going to take the exponent and move it out in front. X times the ln of 3 equals x minus 1 times the ln of 4. Now there's something very wrong here with how I wrote that. I need to put the x minus 1 in parentheses, and I'm just going to put the ln of 4 in parentheses too, just so you can see that's how it should be. So watch your parentheses. Watch your parens. Next, I'm going to distribute. There's no distribution happening on the left, x ln of 3, but there is a distributive property happening on the right side. I'm going to multiply the ln of 4. Remember, the ln of 4 is just a number, so I actually get x times the ln of 4 minus the ln of 4. Okay. My next step is going to be get the x's on one side, get constants on the other. So I'm going to subtract x ln of 4 from both sides, so I get x ln of 3 minus x ln of 4 equals the negative natural log of 4. Now, I've got x, kind of x's on the same side. This is going to be similar to stuff we did before. We're going to factor out an x. So I get x times the ln of 3 minus the ln of 4. Don't worry about combining those. Just keep them as they are. And then lastly, divide. I'm going to get x is equal to the negative ln of 4 over the ln of 3 minus the ln of 4. This is a perfectly acceptable answer. This answer can be expressed in multiple ways, but as an answer on your papers or something, this is something I totally would take, because this is a calculator ready answer. It can be plugged in, it can be approximated in any calculator, and that's good form. Some other forms that you just may want to know, just because it's good math to be able to work them into that, is that really negative ln of 4 is the same as the ln of 4 to the negative 1. And the ln of 3 minus the ln of 4 is the same as the ln of 3/4. And if I really wanted to, I could make this the ln of 1/4 the ln of 1/4 over the ln of 3/4, which would be the log base 3/4 of 1/4. That would be an answer. I could also take this and move the negative. So instead of the negative on top, the negative goes on the bottom, and this gives me the ln of 4 over the ln of 4 minus ln of 3. And then if could possibly work that into the well, if I worked that in the same way, this would be the log base 4/3 of 4. So it's kind of interesting that all of those are the same number, but the best one, in my opinion, is this one, because that uses natural logs. Let's try another example of this, and I would want you to pause the video and try this one on your own. We're going to go 5 to the x minus 1 equals 3 to the x plus 2. Go ahead and pause and try. I'm just going to work it through how I would now. Take the natural log of both sides. Ln of 5 to the x minus 1 equals the ln of 3 to the x plus 2. Then I'm going to use the power rule, move the x minus 1 in front, watching my parentheses. X minus 1 ln of 5, x plus 2 times ln of 3. I'm not going to overuse them now, but I'm just going to keep the x minus 1 and x plus 2 grouped. Use the distributive property, x ln of 5 minus ln of 5 equals x ln of 3 plus 2 ln of 3. Put the x terms on one side and put the constants on the other. So I have x ln of 5 minus x ln of 3 equals 2 ln of 3 plus ln of 5. Factor in x out on the left side. X times ln of 5 minus ln of 3 equals 2 ln of 3 plus ln of 5. And then the last step is to divide. X equals 2 times the natural log of 3 plus the natural log of 5 all over the natural log of 5 minus the natural log of 3. And that would be your final x by itself. It's really an elegant process, and the more you do it, the less difficult it becomes. What's tricky is just checking when you don't actually have to do it. If I give a problem like 7 to the x minus 2 is equal to 10, I can, well, actually I can do this now. This is kind of cool, in my opinion. I can take the natural log of both sides. Ln of 7 to the x minus 2 equals the ln of 10. Then I get x minus 2 ln of 7 equals ln of 10. X ln of 7 minus 2 ln of 7 equals the ln of 10. X ln of 7 is equal to the ln of 10 plus 2 ln of 7. And then x is equal to ln of 10 plus 2 ln of 7 all over the ln of 7. That works. Another strategy is to take this and express it as log base 7 of 10 is equal to x minus 2, and then just say x is equal to the log base 7 of 10 plus 2. And that's an acceptable answer. The directions right now are just going to say solve. So there's multiple ways that you're going to be able to express these. But you do need to know that they are the same thing. I could take this and say that's the same thing as the ln of 10 over the ln of 7 plus 2, and then just add them with an LCD to get back to this. They're all the same. So you're going to have to pick a strategy and sort of recognize there could be multiple strategies. What are you going for? Okay, let's do some other examples. I want to point to two types that we alluded to yesterday. One is if I have the log base 3 of x minus 2 plus the log base 3 of x is equal to the log base 3 of 10. And underneath that, well, actually I'm not going to put underneath it. I don't want to plan my space yet. We're going to do a problem that's very, very similar. Actually, I'm going to show you what we're going to do. Don't write this down yet. I'm going to move it down. This is going to be exactly the same left side, but it's going to be a different right side. See how they're different? Okay, top one, now I'm going to add some space here. Just kind of shift that down. The top one, I can't just drop the logs. First of all, dropping the logs is pooping, and we don't want to poop on this. But what I do want to do is use my log rules to combine those into one single log expression. Log base 3 of x squared minus 2x equals the log base 3 of 10. Now we can drop the logs using the logarithmic property of equality, which states that if I have logs of the same base on both sides and nothing else going on, now I can actually just say x squared minus 2x equals 10. So then I get x squared minus 2x minus 10 is equal to 0. I kind of threw some mean ones in there because this one does not factor. We'd have to use a quadratic formula. X is equal to 2 plus or minus the square root of 4 minus 4 times a negative 10 all over 2. Then I get x is equal to 2 plus or minus the square root of, this would be 44, so let's just say 2 radical 11 all over 2, which is equal to 1 plus or minus radical 11. I'm not done yet. I actually have to check that when I plug them back in that they would both give me real numbers. So 1 plus radical 11 is really like going to be 4 point something. And 1 minus radical 11, because radical 11 is 3 point something, 1 minus radical 11 is going to be negative 2 point something. Well, if I plug the 4 point something in up here, I'm okay. 4 minus 2 is still a positive number, and 4 is a positive number, so we're good. But the 1 minus root 11, if I plug in negative 2 point something up here, it's going to fail that second one. Actually, it's going to fail both of them. It's going to make me take the log of a negative number. So my solution really is 1 plus root 11, not 1 minus root 11. Don't always assume it's going to be the plus one. I could easily turn this around and made this 2 minus x and just started to throw the whole thing off. So just you got to plug them back in. Now the second one is very similar. I would still use the log rules to combine the left side, x squared minus 2x, but I can't drop the logs. I can do one of two things. What I can do is I can convert it to exponential form and say 3 to the 10th power is equal to x squared minus 2x. Or what I can do is actually change the right side to be a log. I can say this is log base 3 of x squared minus 2x equals the log base 3 of 3 to the 10th power. And now I can drop the logs. However you do it, you're going to get to the same thing. This is also a terrible example for me to pick. I just made this up because 3 to the 10th power is an absolutely insanely huge number. Well, not too insanely huge. Let's see what it is. 3 raised to the 10th. 59059. I mean, I'm kind of committed to it. X squared minus 2x minus 59059 is equal to 0. And we'll just let that go. I'm not going to worry about trying to solve that one by hand because I would never give you something that big. Was it 59049? Up 49. At least get that right. But let's, well, if I were to change the right side into a 2, that would have been better. So let's just do one more example, something a little bit cleaner, but I'm going to make a small change. Let's go 2 log base 4 of x minus log of x plus 1 is equal to 1. Okay. First of all, I would not be able to solve this the way it is right now because these are not the same log types. So let's change this to a log base 4. Now they're okay. I'm not going to give you ones that have different logs. We don't know how to do those. So let's do this log base 4 of x squared. I need to change that because I can't use any combining until I make those coefficients become exponents. And this would be minus log base 4 of x plus 1 equals 1. Now I have log base 4 of x squared over x plus 1 equals 1. And like before, when you're stuck, let's just convert it to exponential form. It's in log form. 4 raised to the first power is equal to x squared over x plus 1. And if I do some cross multiplying, I get x squared is equal to 4x plus 4, or x squared minus 4x minus 4 is equal to 0. Quadratic formula, x equals opposite of 4 plus or minus the square root of 16 minus 4 times a negative 4 all over 2, and I get 4 plus or minus, it's going to be root 32, so 4 root 2 over 2, or 2 plus or minus 2 root 2. Same as before, my negative one is not going to work, so whichever one of those would make a negative number, and so I actually got to keep the one with the plus sign, 2 plus 2 root 2. And that would be my final solution. Oops. Lastly, I want you to see these problems that are going to be at the bottom of your sheet. This should be quick. Anytime you need to plug a log into your calculator, and your calculator in testing mode cannot do logs at different bases, remember the change of base. We've done it up above, but just to give you one little refresher, if I do the log base 9 of 1.01 and ask you to find that on your calculator when it's in testing mode, you will have to either type in the ln of 1.01 over the ln of 9, or you'll type the log of 1.01 over the log of 9. Any one of those will do. And just to prove it to you, here it is. All three of them done the same, typed in differently, but done. They're the same thing. Don't make the first time that you do this and the first time that you practice rounding to what it says. I believe it says the nearest the nearest 10,000th. And what would the nearest 10,000th be? That's 4 decimal places, so 0.0045. Don't make the first time you practice this be the test or the quiz. Practice it now. Good luck. See you later.